Hey my lovely level 3s, and welcome back to 3.4 Atomic Structure and Bonding. We're up to lesson 9 on shapes of molecules, and this is part A. So what are our learning objectives for this lesson? It's to describe the shape of molecules which have undergone 5 octet expansion to have 5 or 6 electron density regions, and to be able to draw 3-dimensional shapes for these. So those are our learning objectives, and we're pretty much going to launch straight in. Okay, so how do we even get to a shape of a molecule? Well, to get to a shape of a molecule, we have to have done a Lewis structure. And electron density regions repel each other, so that repulsions are at a minimum. Okay, now we don't draw lone pairs into a shape, but they contribute to those bond angles and are included to make the parent geometry. So you have 2 new parent geometries this year, and if you really switch on to this section of the lesson and then interact in the games we're going to do, it'll actually fully make sense. I kind of think this is like the one lesson where there's kind of 2 sequences, we do 2 lessons on it, and you get it the whole time. So hopefully you've made or you've got together some of the Play-Doh and bamboo sticks that I asked, or toothpicks. So the first shapes that we're going to discuss are the 5 electron density regions, which leads to the parent geometry of trigonal bipyramid. Now, to make a trigonal bipyramid, you guys need to get your Play-Doh, and what you're going to do for me is you're going to stick a bond directly above and below each other, so above and below. Okay, and then you're going to create for me, if I just turn this horizontal, you're going to put 3 bonds in the middle. And so those 3 bonds in the middle look like a trigonal planar. So hopefully that makes sense. I'd love you to pause and make that, so then you can join in with me. Okay, team. So this is your new parent geometry. This is called trigonal bipyramid. Why it's called trigonal bipyramid is if we covered up these, it's hard to do without my sticks all moving. If you put faces on all of these, it would look like 2 triangular pyramids, one on top of one another. So that's why it's called trigonal bipyramid. Okay, the next thing that we need to talk about is to visualize all these shapes. We need to understand that where the lone pairs, now where lone pairs go. So any time that you've got a shape with 5 electron density regions, if there are lone pairs, they always go in this middle plane, this equatorial plane. So the one where there are 3 bonds, and that's every single time. And the reason for that is because lone pairs take up more room, okay, because there's nothing else pulling those electrons, so they repel more. Now, you don't need to know that for your exam. You do if you're doing scholarship, and there's a whole extra section of notes that I won't do a video on, but you can read through if you're doing scholarship, and they're on your OneNote. What do you need to know for level 3? You need to know that if you've got trigonal bipyramid, so 5 electron density regions, and if there are lone pairs, they go in the equatorial plane, which is the middle plane, horizontal plane. Okay, so you guys will be stoked with this. The shapes this year actually make sense and have names that are hilarious. So the first thing that we're going to do is we're going to lose 1 lone pair. So if we've got 5 electron density regions and one of them's a lone pair, and so we're going to lose it from this middle plane always with equatorial. So if we lose 1, okay, which you'll see here, so 1 lone pair. And if you look, this looks like something, because you can do this too, you should be holding yours now. It looks like something that you see at the playground from when you're a kid, that I put Vinny on all the time. So this is a seesaw, because it looks like a seesaw. How crack up's that? So 1 lone pair, okay, and you make a seesaw shape, which is really cool, okay, because it looks like a seesaw. So then back to your trigonal bipyramid, so plug it back in. And what if we have 2 lone pairs? So if you have 2 lone pairs, so pop out 2, always from the middle plane, remember. And actually, what letter does this look like on its side? If we flip it, it is a T, the letter T. So this shape is called T-shaped, which is pretty awesome. And then the last one, if we put them all back together, I do this every time just so you get the right idea. So put them back in, okay. What if we lose all 3 from this middle plane? And if you lose all 3 from the middle plane, this looks like a shape that you've previously learnt before, which is linear. But this time this is linear with 5 electron density regions, which is pretty crazy. So let's just go through those again, okay? And honestly, by the end of this lesson and our games that we're going to play over the next 2 lessons, you'll have these shapes totally sorted because they make sense. So when there are 5 electron density regions, and they're all bonded, there's one bond above and one below. This plane, the vertical plane, is called the axial plane. And you've got 3 bonds in the horizontal plane, okay, creating a 120 bond angle, okay, and that's called the equatorial plane. So this is trigonal bipyramid. You need to memorize that name, and that's for 5 electron density regions. If there's ever a lone pair, it always goes in that middle plane, and that's because lone pairs take up more room. So if we take off 1, then we end up with the first shape, which is a seesaw, okay? And then if we take off 2, you end up with a T-shape. And then if you take off 3, you end up with linear. So those are your new shapes, which is really cool. And it's as easy as that. And remember, bond angles are always determined by the parent geometry. So we need to look back at our parent geometry here, our trigonal bipyramid, to work out what the bond angles are. So this one here is a little bit trickier probably than any other shape that you're going to do, and that's because there's actually 2 bond angles. So if you look here, I'm just going to hold this to the camera. Hopefully you can see my finger going like this. What's this bond angle here? It's a right angle, so that means that it is 90 degrees. So there's a 90-degree angle between the axial plane and the equatorial plane. And then the next angle we've got to look at is this one here in the equatorial plane, and this bond angle is 120. Okay, 120. And if you lose lone pairs, the bond angles are actually always to do with the remaining bonded pairs. So we don't worry about, well, whoa, there's a gap there now. Okay, so if we took off 1, okay, here, so I've created my seesaw. Okay, my seesaw. Well, then the bond angle still here is 90. And then the bond angle here between these equatorial bonds is still 120. So the bond angles come from that parent geometry. And for trigonal bipyramid, there are 2 bond angles, 90 between the axial and the equatorial, and then there's 120 degrees for that between the equatorial. Hopefully that makes sense. So now there's a second shape I'd like you to make. You're going to get your next ball, and you are going to make for me 1 bond up and down, okay, in the axial plane, and then 4 bonds. So 4 bonds in that middle plane. 4 bonds in that middle plane. Okay? And because there's 4 bonds, they look like a 90-degree angle to each other. It's quite hard, I know, to keep these kind of neat and tidy. Okay, so all of the bond angles for this shape are 90 degrees. Hopefully that's what yours looks like. I know they're a bit fiddly. So there are 6 electron density regions here, folks. 6 electron density regions. There's 1 up and down in the axial plane, and there's 4 in the equatorial plane. And yeah, all bond angles 90. So that's nice and easy. So the difference between this parent geometry, which is called octahedral, by the way, and the reason why it's called octahedral is if you covered in the faces with bits of paper, it would make an octahedron. And so this time, instead of the lone pairs going in the equatorial plane, the lone pairs this time are going to go in the axial plane. So here, if all of them are bonded, we have octahedral, and then if we have 1 lone pair, to take 1 off, this is actually called a square-based pyramid, because if you put faces on this, it would be a pyramid with a square bottom. Okay, so square-based pyramid, and you need to learn that. And then what if there were 2 lone pairs? So we lobbed off another one. You would have square planar. So this is called square planar because all the bonds are in the plane of the page, and hopefully you can make them with me. So square planar in the plane of the page. Okay, square-based pyramid, square-based pyramid. And then if all of them are bonding, you've got octahedral, octahedral. So these are your new shapes for this year. So you have to know the 2 new parent geometries, which are, just trying to get that back into its nice little shape here. So you've got trigonal bipyramid, okay, with 5 electron density regions, and octahedral with 6. And we're going to play a game together to memorize these on teams, but that's essentially it. Okay, so you've learned where the lone pairs go and how the shapes are created. I'm just going to flick through now just to compare all the shapes and this is how they're drawn, just so you guys can see. So this is your, from level 2, your trigonal planar. It's a planar shape. Tetrahedral, okay, is 3-dimensional, trigonal pyramid, and bent. Okay, so here's this year's shape. So this is the one that I'm focusing on now. So here is your trigonal bipyramid. Remember, you've got a bond above and below, and then 3 in the middle. So mine just looks a bit ugly at the moment. Apologies for that. So here's mine, trigonal bipyramid. So if you kind of hold it to the side, guys, and you can make a T. So here's the T, all in the same plane. And if it's in the same plane, they're given a straight line. Okay, if it's all in the same plane, they're given a straight line. So up, across, and down. Looks like a T. They're in the same plane, so that's why it's drawn like that. Then there's one pointing towards me, which is the solid. And there's one pointing towards you, which is the dotty. And that's how we draw trigonal bipyramid in 3D. So that's why these pseudo mods are really good to visualize this. So then the second one, seesaw, when we've lost one. Okay, so we've lost a pair around the middle. Okay, which you can see there. The easiest way is to keep that T, well, up to you. You can either draw it looking like a seesaw, or you can keep that T and just lob off one of these, whichever you find easiest. Okay, a lot of kids find it easier just to lob off one of the 3-dimensional. And then if you lose another one to do T-shape, oh sorry, that was your seesaw. And if you lose another one to do T-shape, that's a planar shape, right? So you just literally have a T, nice and easy. So hopefully you're visualizing that. These do take a bit of practice, but we will do some. So what if there's another one lost? Then again, that's a planar shape. Okay, it's just linear. And because you don't draw these, you don't draw the lone pairs. So going back through, linear, planar, T-shaped, planar, we don't draw those. The next one is seesaw. Okay, so seesaw, you can either draw it like this, keeping these ones in, or you can just lob off one. I think it's easier just to lob off one. Okay, and then the actual full shape. Okay, you have T in the plane, and then you've got one pointing towards me slightly and one towards you slightly, and that gives you the shape. Hopefully that makes sense. So now we're going to do octahedral. So you've got 4 in the middle and you've got 1 up and 1 down. So here's my octahedral. Okay, this is not drawn in 3D right now, so I need to quickly correct it for you. So straight up and down are the only 2 planar. That's it. All the rest of them have to be angled, because if you're holding this right now, you should be seeing that 2 are pointing towards you and 2 are pointing towards me. So the 2 towards me are the solid, so that should be a solid line. And these pointing backwards should be dotty, okay, because they're pointing outwards towards you. And so this has to be a 3-dimensional shape. So then this one here, they've actually drawn it correctly. So this is square pyramid. So if you take off that bottom one, so you just ignore this one, and then it just stays as we had before. So it's actually really simple. If you learn how to do the parent geometry in 3D, then you just lob off one each time and it kind of makes sense. And then the second one, okay, now this is not how I would draw this, okay? So I always do this to show you here. So if we've taken off 2, square plane is actually a planar shape. You can draw it like this and you would get the mark, because technically you could hold it like this, and that means 2 bonds are towards you and 2 bonds are towards me. But the easier way to do this is to do ZE, boom, 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 and make it a planar shape. So either of these are acceptable and you'll get the mark. Okay, cool. So why do shapes have these names that we see and that we've been talking about? And that's purely because if you filled in the faces with bits of paper, that's the shapes they take on. Okay, that's purely the reason. So here are our new parent geometries for this year. So from last year, linear, trigonal, planar, tetrahedral, and your new ones, trigonal, bipyramid, and octahedral. Okay, and just a reminder, they go, if you've got 5 electron density regions, they go in the axial, the equatorial plane, the middle plane, and if you've got 6 lone pairs, go on the axial plane. Cool, so we'll be back in a second for how to justify these shapes. I'll see you soon.